Hi, my name's Matt. I'm a geology professor and a field geologist, and I want to talk about this.
Is this proof that the Bible is true? My response to a content creator who is sharing what they believe to be archaeological evidence that proves the Bible to be true.
Not only do we find petrified wood in the shape of a boat in the exact location that the Bible says, it's also to the exact measurements that the Bible says.
This is also all entirely made up. This is another fantasy that was promulgated by Ron Wyatt.
This is probably going to be part one of many, shooting down some of the ideas that the geologic record supports some of this biblical narrative. You should go watch Dan McClellan's video number. Let's start with the biggest fish. Is this Noah's Ark? Let's look at this structure together. All right, so immediately I look at this structure, and the first thing I think is this looks an awful lot like a fold. And rocks are folded all the time. It's very common, specifically in areas where mountains have been constructed. This is an area, without looking any further, there is the structure interpreted to be Noah's Ark. We go up, if you look in the distance, you can see some of those rocks are tilted in the far distance. Let's pan over here. These rocks, the green-gray rocks real close there, are dipping away from us. We rotate around, and here's the really cool shot. I'm going to zoom right in. The rocks on the right are dipping to the right. The rocks in the distance to the left are not only dipping to the left, but if you notice, they turn very quickly and drop straight down. These rocks are intensely folded. So could this be a fold? There's a fold right in front of you. If you look in the distance, you can see a fold. In fact, without any other information, that looks like what we call an overturned fold, where the rocks have been folded and then tilted over. So is there folding in the area? 100%. Could this be a fold? 100% it could be, okay? Look, right there. There's one in front of your face. Let's go down here. That's the same thing. But instead of looking at the rocks tilted like this, you're now looking at them almost bowled up, right? Kind of like my hands. Now, it kind of does look like a boat, but I can show you another example. To Chandler Mountain, Alabama. There is Chandler Mountain, Alabama. Tell me that doesn't look like a boat. No, it's not. It's folded rocks that are between 300 and 360 million years old. It's a massive mountain. It's several miles long. It's huge. But that is the exact same structure, and it's the exact same format and shape as the structure that was in Turkey. So could the, quote, Noah's Ark structure be a fold? It absolutely could be. So let's make another hypothesis. The other hypothesis is this looks an awful lot like what is called a cinder cone volcano, right? And this area is known for volcanism. Those are two massive volcanoes. Those are called stratovolcanoes, different type of volcano, but volcanism is active in the area. If you look in the distance, there are several craters on the far side that are volcanic. And let's build this hypothesis a little bit. If you look in the foreground, right here with these green-gray rocks right there, those are dipping away from us at an extremely steep angle. If you look here, these rocks are very shallowly dipping towards the middle. And so that's what we would call the discordance, the angle between two beds. And that seems to be a high discordance angle. That's a little tricky to make that work with a fold because the rocks would have to come up and then really rapidly get flat. And so you would either need a fault potentially in there, maybe there is one, but that is a problem with hypothesis one, is there is some discordance between that bed. That does not mean hypothesis one is either one, wrong, or two, unlikely. It is just a point that we would need to solve if we were going out in the field. So the second hypothesis is that this is volcanic. Very specifically, I would call this a fissure cinder cone. What happens is when a volcano can break to the surface through a fracture network, it gets to the surface and it has multiple little vents and they're all kind of lined up, and it makes a structure exactly this size and shape. It looks just like this. Don't believe me? Here's an active one of these in Iceland in 2003. If you remember the volcano that threatened to take out the town of Grindavik in Iceland, it was all over the news. This is it. So this is some drone footage we flew around the area. The length of this structure is very similar. If you imagine there's no lava there, this is about the same shape. When a little bit of erosion hits these things, it looks almost identical to the structure we see here. So those are two hypotheses to naturally explain the presence of this structure. This is classic textbook geomorphology interpretation. it's going to either be a fold or a cinder cone. If it was much larger, I would say fold for sure. But given the fact that it's in this kind of intermediate scale, could very easily be a cinder cone too. Is it Noah's Ark? No. So here's the thing. It's not Noah's Ark, but it's kind of cool. Look. So what's cool to me, if it's a fold, which it probably is, if you see in the middle, it looks like the nose extends out, and if you see that little pointed area right there, it points that way. There's another little nose over there. So that means what we would call the axis of that fold has to go through here and curve really quick. That's kind of cool. That means that the fold is also folded. That's neat. If it's in fact a cinder cone, that's pretty cool too, because volcanoes are cool, man. So just because it's not Noah's Ark doesn't mean it's not a cool structure. Fold or a volcano, your call. It's one of the two, but it's cool.